Alright, hello everybody. In this video, I'm going to go over where the derivative of secant comes from. So, I really like to go over proofs and things just so I can kind of justify things in my head. Okay, this comes from this comes from that. Um, and this video is going to go specifically over secant. So, you don't usually use the derivative of secant very often, but it's always nice to know, and always just kind of like as a bit of a mathematical exercise. Like if I needed to know what the derivative of secant was on a test and I didn't know and I forgot, I could always go and find it this way. So, um, uh, before we actually try and tackle secant straight on, let's think of different ways where we can kind of express secant of x. Um, that we might be familiar with, right? So if you've taken some trig classes, hopefully you're aware that secant, that secant of x is just equal to 1 over cosine of x, right? And it's kind of confusing because like, oh, cosecant, oh, that must mean cosine, right? But it's the opposite of what you think. Secant is 1 over cosine. So, but if we think about it, in this video, we're kind of assuming that we already kind of know what the derivative of cosine of x is, at least, right? So, um, I'll write this here just so we can reference it if needs be. So the derivative of cosine is equal to negative sine of x. Okay, so here we go. So we know how to derive cosine of x. The only kind of hiccup is it's 1 over cosine of x, so that kind of makes things a little weird. So the cool thing about a lot of things in math is that there are multiple ways to get to one spot. So I'm going to differentiate this in two ways. First things first, I'm going to differentiate this using quotient rule. And then another way I'm going to use is actually chain rule, which is going to be kind of interesting. So to begin, I'm going to start with quotient rule. So I'm going to quickly write down what quotient rule, like the definition of quotient rule, just so we can remind ourselves and reference it if we need it. So the quotient rule states that if we have the quotient of if we're taking the derivative of the quotient of two functions, this is going to be the same thing as f prime of x times g of x minus f of x g prime of x. Okay, and I'll put all of this over g of x squared. So hopefully you're familiar with quotient rule. Hopefully this isn't the first time you've seen it. Um, yeah, I would definitely recommend you're familiar with it if you're uh, going into this video because it's a helpful one to know. So okay, so let's use a quotient rule to see if we can help us out here. So let's see if we can take the derivative of 1 over cosine of x. Let's think of 1 as our first function because 1 is still technically a function. We can think of it as a function, which is pretty cool. So um, well, 1 is my f of x and cosine of x is my g of x. So let's go ahead and use quotient rule. So the derivative of 1 is just 0, right? So I'm going to be multiplying 0 by g of x. So I'm just going to write 0. And then minus, I'm going to do the minus here, f of x, so this will be 1 times g prime of x. So g prime of x, this is negative sine of x. I didn't write that times 1 just because it'll just be itself here, right? Okay, and this will be over cosine squared of x. All right. Okay, so real quickly, I'm going to rewrite this as sine of x because I just have a negative of a negative, right? So sine of x over cosine squared of x. Okay, now from here, I'm going to kind of break this into two different parts, just so we can kind of see where this is coming from. I'm gonna break this into two fractions per se. I'm gonna say this is the same thing as sine of x over cosine of x times 1 over cosine of x. So if you think about it, when you're multiplying fractions, you just multiply the tops and the bottoms, and then you'd be left with sine of x times 1 is just sine of x, cosine of x times cosine of x is just cosine of x squared. So don't worry, these are still the same things. And then from here, we can actually rewrite this into forms that we might recognize, like on a test or something like that. So sine over cosine, that's just tangent, right? If you've taken a trigonometry class, when you go over the unit circle, you'll learn that tangent is just sine over cosine, and times 1 over cosine. I can't forget my 1 over cosine. So remember, we decided that, well, 1 over cosine the secant is just 1 over cosine, right? So we can rewrite this as secant of x, just like this. Um, so that's kind of cool, right? That the derivative of secant has a secant in it, and then you just like put on a tangent there just to seal the deal. It's kind of cool. So hopefully that helps with your remembering where like what the derivative of secant is. You can think, okay, it's just the derivative of secant is just it's just secant times tangent kind of. Um, and of course, if you ever forget, you can go through this whole process again, just using logic and knowing what the derivative of cosine is, and then going through quotient rule, and then you'll be able to come to that answer. Okay, so now I'm going to try and quickly erase some stuff on my screen just so we have some more breathing room, and let's try and use chain rule to find this out. Okay, so we went over that secant of x is just equal to 1 over cosine of x, right? Okay, so we can also think of this as cosine of x to the negative 1 power, right? Because if you have 1 over if you have like 1 over something, it's just the same as bringing it to the negative 1 power, right? So we can actually sneakily use chain rule to see if we can figure this out. So let's use chain rule to figure out what the derivative of cosine of x to the negative 1 power is, and maybe it'll help us out and we can do it this way. So, okay, from here, I'm going to, using chain rule, I'm going to, first things first, I'm going to imagine that this is just like a normal function, right? It'll just be like x to the negative 1. So I'm going to bring down that negative 1, cosine of x, and then I'm going to decrement the exponent by 1, right? So this is what I'm left with. And remember, I have to multiply by the derivative of the inside. So the derivative of the inside, it looks like, real quick, I'll write the derivative. Oh yeah, so the derivative of cosine is just negative sine, right? So negative sine of x. Okay. All right, here we are. So we use chain rule, and let's see if I can rewrite this just to make it look a little bit more recognizable. So, okay, I'm going to say this is the same thing as, it looks like I have a negative 1 times a negative sign, right? So I'm just going to cancel out that negative. It's just going to be positive. So this leaves me with 1 over cosine squared of x, right? That's a way of thinking about cosine of x to the negative second power, right? So I'm left with cosine squared of x times sine of x. I think of it as like this, right? Okay, so that leaves me with sine of x over cosine squared of x. And hopefully this gives you deja vu, because now we're suddenly in the same place, right? So I kind of ran out of room on this side, so I'm going to continue where I was here. Okay, so I'm going to, like I did before, I'm going to break this up. So I have sine of x over cosine of x times 1 over cosine of x. And like we said, this is just tangent. And this is just secant, right? So we were able to find the derivative of secant using 2 different ways, both chain rule and quotient rule, which is super cool. So if you do end up in a situation where you're taking a test and you're trying to figure out what the derivative of secant is, it's nice to know that you have 2 different ways to go about it. And I recommend going with whichever one you're most comfortable with, right? Me personally, I think I would probably take the chain rule route, because I think there's really less opportunity for me to make a mistake here, but really it's up to you. So anyway, I hope you found this video helpful. Just went over the proof of the derivative of secant. It was pretty cool, and I will see you in the next one.